students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as matrices. Let's see this. Let's see how do you express the following equation or solve using matrix method. The equations are given to you as 2x minus 4y plus 3z is 1, x minus 2y plus 4z is 3, 3x minus y plus 5z is 2, right? Let's see this. How do we solve this? The first thing that you need to do is you have to convert this in matrix form. I can say that the above equation in matrix form two, 1, 3 minus 4 minus 2 minus 1 3, 4, 5. Write all the x coefficients one below the other, write all the y coefficients one below the other, write all the z coefficients one below the other. Right? Once you've done that, then you write x, y, z. Then the right hand side 1, 3, 2. Right? Now you've got to convert this into an identity matrix. Now if you remember your identity matrix, I have to have the number in the first position as 1. So what you're going to do is you're going to interchange R2 and R1. Interchange R2 and R1. If I interchange R2 and R1, I'll get 1 minus 2, 4, 2 minus 4, 3, 3 minus 1, 5. X, Y, Z. 3, 1, 2. Right? Yes. No, you don't change the X, Y, Z. You've already done one change on the left hand side, you do one change on the right hand side, I've changed this 3, 1, 2, I've done it, right? Now I need to have the number in the second and the third position as 0, right? Now, where is the number in R2? What is the number 2? Complement of that is minus 2, R1. Similarly, R3 minus 3, R1. So in which case you will get this as 1 minus 2, 4. 2 minus 2, 0, minus 4 plus 4, 0, 3 minus 8, minus 5. Now 3 minus 3, 0, minus 1, minus 1, plus 6, 5, and this is going to be 5 minus, this is 5 minus 12, right? So that's minus 7. So in which case you will get this as x, y, z 3. Now R2 minus 2, R1. R2 minus 2, R1. R2 is 1 minus 6 minus 5. Right? Then similarly you have 2. You have 2 minus 9 minus 7. Now there is no way I can get 1 here because I already have a 0 here. Right? There is no way I can get a 1 here because I have a 0 here. So what I'm going to do now is, guys, I'm going to interchange R2 and R3. I'm going to interchange R2 and R3. So in which case I'll get this as 1 minus 2, 4, 0, 5 minus 7, 0, 0 minus 5. X, Y, Z is 3 minus 7 minus 5. Now in spite of interchanging, I cannot get a 1 here because the number here is 0. So instead of solving the second row, now I'm going to solve the third row. Right? I'm going to make this number as 1. How do I make this number as 1? Divide R3 by minus 5. If I divide R3 by minus 5, I'll get 1 minus 2, 4, 0, 5, minus 7, 0, 0, 1. X, Y, Z is 3 minus 7, 1. Right? Once you have this, now I'll finish solving the third column first. I need to make these two numbers as 0. Where is the number in R1? What is the number of 4? Complement of 4 minus 4, R3. Similarly, where is the number in R2? What is the number? Minus 7. Complement of minus 7 is plus 7, R1. Fine? Now, this can be written as 1 minus 0, minus 2 minus 0, 4 minus 4, 0. Then 0 minus 0, 5 minus 0, minus 7 plus 7, 0. 0, 0, 1. X, Y, Z. Now, 3 minus, this is going to be 3 minus 4, minus 1, right? This is going to be minus 7 plus 7, minus 7 plus 7, 0, and this is going to be 1. Now I need to make this number as 1, so I'll divide R2 by 5. If I divide R2 by 5, I'll get 1, 0, 1 minus 2, 0, 0, 1, 0, 0, 0, 1. X, Y, Z. Minus 1, 0, 1. I've divided R2 by 5. Now I need to make this number as 1. Where is the number in R1? What is the number? Minus 2. Complement of that is plus 2. R2. So this is going to be 1 minus 2 plus 2. 0, 0, 0, 1, 0, 0, 0, 1. X, Y, Z is equal to minus 1 plus 0, 0, 1. Right? Now this is an identity matrix. That means I can therefore say that X, Y, Z is equal to minus 1, 0, 1. Therefore you could say that X is equal to minus 1, Y is equal to 0, and Z is equal to 1. Fine, do we understand here? So do we understand how do we solve this using matrix method? Let's see another sum, guys. Solve using matrix method. X minus y plus z is 1. X plus 2y plus 3z is 8, and 3x plus y minus 4z is 1. Right? How do I solve this? First, convert the equation into matrix form. I can say that the above equation in matrix form (2, 1, 3) minus 1, 2 minus 1, 2, 1 and 1, 3 minus 4. X, Y, Z 181. Right? So what have we done here? We've converted the above equation into matrix form. Fine. Now, once this is done, I need to have the number in the first position as 1. How do I get the number in the first position as 1? Interchange R2 and R1. If I interchange R2 and R1, I'll get this as 1, 2, 3, 2 minus 1, 1, 3, 1 minus 4. X, Y, Z. I'm interchanging R2 and R1. Right? Now once I have done this, I need to make the number in the second and the third position as 0. So this is going to be R2 minus 2R1 and R3 minus 3R1. 1, 2, 3. R2 minus 2R1. 2 minus 2, 0. Minus 1, minus 4, minus 5. 1, minus 6, minus 5. Next, 3 minus 3, 0. 1, minus 6. This is going to be 1 minus 6 minus 5, and this is minus 4 minus 4 minus 9, minus 4 minus 9 minus 13. X, Y, Z. 8. This is going to be 1 minus 16, that is minus 15, and 1 minus 24 minus 23. Right? Now I need to make this number as 1. Now I cannot subtract it and make it as 1 because this number is also minus 5. So what I'm going to do is I'm going to divide R2 by minus 5. So if I divide R2 by minus 5, I'll get 1, 2, 3, 0, 1, 1, 0 minus 5 minus 13. X, Y, Z is 8, 3 minus 23. Right? Now, once you have this, I need to make the number in the 4th and the 6th position as 0. So this is going to be R1 minus 2R2 and R3 plus 5R2. Right? So in that case, this is going to be R1 minus 2R2, 1 minus 0, 2 minus 2, 0, 3 minus 2, 1, 0, 1, 1. Now R3 plus 5R2, 0 plus 0, minus 5 plus 5, 0, minus 13 plus 5 is going to be 8. Minus 13 plus 5, minus 8. X, Y, Z is going to be equal to, now R1 minus 2R2. So 8 minus 6, that is going to be 2, 3 as it is, minus 23 plus 15. Minus 23 plus 15 will give you minus 8. Now I need to make this number as 1. So I'll say R3 divided by minus 8. If I divide R3 by minus 8, I'll get 1, 0, 1, 0, 1, 1, 0, 0, 1. X, Y, Z is 2, 3, 1. I'm dividing R3 by minus 8. Once I've done that, now I need to make the number in the 7th and the 8th position as 0. So this will be R1 minus R3 and R2 minus R3. So in which case you will get 1 minus 0, 0 minus 0, 1 minus 1, 0, 1, 1 minus 0, 1 minus 1, that's 0, 0, 0, 1, X, Y, Z, 2 minus 1, 3 minus 1, 1. This is nothing but I, so you will get X, Y, Z is equal to 1, 2, 1. Therefore, I can say that X is equal to 1, Y is equal to 2, and Z is equal to 1. Right? That's how I get the value of X, Y, and Z. Right? Next, let's see another sum, guys. So this was matrix method. Let's see another method of solving this. Suppose if I tell you that solve by deduction method. Right? Reduction method. 2x plus y plus z is equal to 2. X plus y plus z is 0. 4x minus y minus 3z is 20. Right? They've asked you to solve it by reduction method. Whether reduction method or matrix method, you start the sum in the same manner. So you will say that the above equation in matrix form this is 2 1 4 1 1 minus 1 1 1 minus 3 x y z 2 0 20. Right? Now I need to have the number in the first position as 1. So I'll interchange R2 and R1. If I interchange R2 and R1, I'll get 1 1 1 2 1 1 4 minus 1 minus 3 x y z. I'm changing R2 and R1, so 0 to 20. Now I need to have the number in the second and the third position as 0. R2 minus 2R1, R3 minus 4R1. So in that case, this is 1 1 1, R2 minus 2R1. So 2 minus 2, 0, 1 minus 2, minus 1, 1 minus 2, minus 1, 4 minus 4, 0, minus 1, minus 4, minus 5, minus 3, minus 4, minus 7, x, y, z, 0 to 20. The right hand side won't change because as it is R1 is 0. So 2 minus 0 and 20 minus 0. Okay. Now, when they tell you reduction method, you don't have to make the number in the fifth position as 1, but you have to make the number in the sixth position as 0. In reduction method, you have to make the number in the sixth position as 0. This number has to be made 0. Okay. How do I do this? First, write these numbers as it is. Minus 5 and minus 1. What have I done? I have written the number in the fifth and the sixth position. Right? This is going to be R2 and R3 and a subtraction sign between them. And R3 has to change. Right? Once again, I'll show you this once again. What you do is you write the numbers which are there in the fifth and the sixth position. Write the numbers which are there in the fifth and the sixth position. Either way. Right? Write the numbers which are there in the fifth and the sixth position. This is going to be R3 and R2 multiplied by the other row. If you are writing the number in the fifth position multiplied with R3, the number in the sixth position multiplied with R2 and put a minus sign in between. Fine, do we get this in clear? And R3 has to change. So in that case, this is going to be 1 1 1 0 minus 1 minus 1. Now 0 minus 0, 0. Minus 5 into minus 1. See guys, it is minus 5 into minus 1 minus 5 into R2 minus 1. So in that case, this is going to be 5 minus 5, which is 0. Right, that's how I'll get my 0. Now similarly for the third element, minus 1 into R3 minus 7 minus 5 into R2 minus 1. So this is 7 minus 5, which will be 2 x, y, z 0, 2. Now let's see the right hand side. This is minus 1 into 20 minus 5 into 2. So this is nothing but minus 20, minus into minus plus 10. So this will give you minus 10. Right? Once you get this, the number in the sixth position as 0, you convert this back into algebraic form. convert the equation back to algebraic form. So in which case, therefore, you can say that x plus y plus z is 0, minus y minus z is 2, and 2z is minus 10. Convert the equation back into algebraic form. Now if 2z is minus 10, then I can say that z is equal to minus 5. If 2z is minus 10, that means z will be minus 5. Substitute the value of z in the second equation. I can say therefore minus y minus z is 2. So minus y plus 5 is 2. Minus y is 2 minus 5. Minus y is minus 3. Y is 3. Once I come to know y, I can substitute the value of y and z in equation 1. X plus y plus z is 0. X minus 2 is 0, x is equal to 2. Right? Thus I get the value of x as 2. Therefore I can say that x is equal to 2, y is equal to 3, and z is minus 5. That's how you do reduction method. Right? So in reduction method there is no need for you to make it into an identity matrix. All you have to do is, once you finish the first column and the second column, you have to only make the number in the sixth position as 0. Right? Let's see one more sum of this kind, guys. 4x minus 3y plus z is 1, x plus 4y minus 2z is 10, 2x minus 2y plus 3z is 4. Now let's see this. I can say that the above equation in matrix form, equation in matrix form, 4, 1, 2, minus 3, 4, minus 2, minus 1, no, 1, minus 2, 3, x, y, z, 1, 10, 4. Fine. So I have the equation now in matrix form, that's 4, 1, 2, minus 3, 4, minus 2, 1, minus 2, 3. Once you have this, I need the number in the first position as 1. So I'll interchange R2 and R1. If I interchange R2 and R1, I'll get this as 1, 4, minus 2, 4, minus 3, 1, 2, minus 2, 3. X, Y, Z. 10, 1, 4. Right? So I'm interchanging R2 and R1. Once you've done this, now I need to make the number in the second and the third position as 0. Right? So this will be R2 minus 4R1 and R3 minus 2R1. So in that case, you will get this as 1, 4, minus 2. Now this is going to be 4 minus 4, 0. Minus 3, minus 3, minus 16, minus 19, then it is 1 plus 8, that is going to give you 9. Next, 2 minus 2, 0, minus 2, minus 2, minus 8, minus 10, 3 plus 4, 7. X, Y, Z, 10. Now R2, 1 minus 40, minus 39. Then you have 4 minus 20, 4 minus 20, minus 16. Right? Now, guys, once you have this, you have to make the number in the sixth position as 0. How would you do that? Write the number in R2 and R3. Write the numbers in R2 and R3. Right here R3, right here R2, and put a minus sign between them. Right? Now, once you have this, let's see this. This is going to be 1, 4, minus 2, 0, minus 19, 9, 0, minus 0, 0. Now, this is going to be minus 19 into minus 10 minus 10 into minus 19. So this is 190 minus 190, which will give you 0. Right? Next, this is minus 19 into 7 minus 10 into 9. minus 133 plus 90. So this is going to give you minus 43. X, Y, Z. This is 10 minus 39. Now this is going to be minus 19 into minus 16 minus 10 into minus 39. 16 9s are 144. Carry over 14. 16 20 30. 304 minus 390. That is going to be minus 86. Right? Once you have this, convert this back into equation or algebraic form. So this can be written as x plus 4y minus 2z is 10 minus 19y plus 9z is minus 39 minus 43z is minus 86. Right? In which case you will get that z is equal to 2. Z is going to be minus 86 divided by minus 43. Once you have Z, substitute Z. So in that case you will get minus 19y plus 18 is minus 39 minus 19y is 39, 49, 58. Right, minus 58. So y will be equal to 3. 57, sorry. Y will be equal to 3. Once you have this, then you will get x plus 4y, that is 12 minus 2z, 4 is 10. So x plus 8 is 10. So x is equal to 2. Thus you get the value of x as 2, y as 3 and z as 2. Right? So you will get the value of x, y and z as 2, 3 and 2. Right? Next, let's see another sum, guys. Solve using inverse method. X plus y plus z is 9. 2x plus 3y minus z is 9. 3x minus y minus z is minus 1. Right? Now, when they tell you to solve using inverse method, first thing, let's convert this into matrix form. So I can say that the above equation in matrix form one, two, three, 1, 3 minus 1, 1 minus 1 minus 1, x, y, z is 9, 9 minus 1. Right? Now once you have this, I can say, let us assume, when they say inverse form, let us assume that the first matrix is A. So A is 1, 1, 1, 2, 3 minus 1, 3 minus 1 minus 1. Let us assume B is X, Y, Z. And let us assume that C is 9, 9, 1. Right? So the three values that you have to first assume them to be A, B and C. Right? So in that case, I can therefore say that the above equation is in the form A into B is equal to C. Okay? Now, let's find out determinant of A. Determinant of A. How do I find out determinant of A? This will be 1 minus 3 minus 1 minus 1. This is minus 2 plus 3 plus 1. This is minus 2 minus 9. So in that case, this is going to be minus 4. This is 1 into minus 1. So that's minus 1. And this is going to be minus 11. So in that case, this is going to be minus 16, which is not equal to 0. So the first thing that you have to find out, determinant of A and prove that it is not equal to 0. So when you are doing inverse method, first thing you have to do is find out determinant of A and prove that it is not equal to 0. As determinant of A is not equal to 0, therefore A inverse exists. Right? Now, we know that A into A inverse is going to be I. A into A inverse is going to be I. Let's first find out A inverse. A, we have found out as 1, 1, 1, 2, 3 minus 1, 3 minus 1 minus 1 into A inverse is I. I is 1, 0, 0, 0, 1, 0, 0, 0, 1. Right? Now I need to make A into an identity matrix. Right? Let's see how I'll make A into an identity matrix. Right? So in that case, I can say that R2 minus 2R1 and R3 minus 3R1. So in which case you will get this as 1, 1, 1, 2 minus 2, 0, 3 minus 2, 1, minus 1, minus 2, minus 3, 3 minus 3, 0, minus 1, excuse me, which one, this one? Next, minus 1, minus 3, minus 4, then you have minus 1, minus 3 again, so minus 4 into A inverse is 1, 0, 0, now 0 minus 0 minus 2, 1 minus 0, 0 minus 0. Then you have 0 minus 3, 0, 1. Okay. Now the number in the fifth position should be 1, it is already 1. The number in the fourth and the sixth position have to be made 0. So R1 minus R2 and R3 plus 4R2. So in which case you will get this as R1 minus R2, 1 minus 0, 1 minus 1, 1 plus 3, which will give me 4, 1 plus 3, 4. Then you have 0, 1 minus 3, R3 plus 4R2, 0 plus 0, minus 4 plus 4, 0. You have minus 4 minus 12. That is going to give you minus 16 into A inverse is going to give you now R1 minus R2. So 1 plus 2, 3, 0, minus 1, 0 minus 0, then R2 as it is. Then you have minus 3 plus 4, that is 1, minus 3, minus 3, minus 8, minus 11, then you have 0 plus 4, that is 4, then you have 1 plus 0, that is 1, right? Now I need to make the number in the ninth position as 1. How do I do that? Divide R3 by minus 16. If I divide R3 by minus 16, I'll get 104, 0, 1 minus 3, 0, 0, 1 into A inverse is 3 minus 1, 0, minus 2, 1, 0. I'm dividing by minus 16, so this is 11 upon 16. This is 4 upon minus 16, so that's minus 1 upon 4, and this is minus 1 upon 16. Now I need to make the number in the 7th and the 8th position as 0. So this will be R1 minus 4R3, and this is going to be R2 plus 3R3. So in that case, this will become 1, 0, 1, sorry, 1, 0, 0, 0, 1, 0, 0, 0, 1 into A inverse. Okay, this should be interesting now. 3 minus 4 into 11 by 16. 4 ones are 4 fours are. So 3 minus 11 by 4. 4 threes are 12. 12 minus 11. 1 by 4. Right? Next. Minus 1 minus 4 into minus 1 by 4. So this will be minus 1 plus 1. 0. Next. This is 0 minus 4 into minus 1 by 16. So minus into minus plus 1 by 4. Next. Excuse me. Next. Minus 2 plus 3 into 11 by 16. Right? So this is going to be minus 32 plus 33 by 16. So that's 1 by 16. Next. You have 1 plus 3 into minus 1 by 4. So you have 1 minus 3 by 4. 4 minus 3. That's 1 by 4. Next. 0 plus 3 into minus 1 by 16. So that's minus 3 by 16. 11 by 16. Minus 1 by 4. Minus 1 by 16. Right? This will give you the value of A inverse. Right? And you simplify, this is going to be I. So therefore I can say A inverse is going to be 1 by 4, 0, 1 by 4, 1 by 16, 1 by 4, minus 3 by 16, 11 by 16, minus 1 by 4, minus 1 by 16. Right? But guys, we had said that AB is equal to C. Right? Now, if AB is equal to C, pre-multiply this equation by A inverse. If I pre-multiply by A inverse, that means I'll get A inverse into AB is A inverse into C. Fine, do we get this thing here? Now, in that case, I will get this as A inverse into A into B is nothing but A inverse into C. A into A inverse is going to give me I, because minus 1 plus 1, that will give me A raised to 0. Anything raised to 0 is 1. 1 is written as I. Right? So I'll get therefore B is A inverse into C. Guys, I'll continue the sum that side. I'm continuing the sum here, guys. So you have B is equal to A inverse into C. B. What was the value of B? The value of B was XYZ is equal to A inverse. You just found out the value of A inverse to be 1 by 4, 0, 1 by 4, 1 by 16, 1 by 4, minus 3 by 16, then 11 by 16, minus 1 by 4, and minus 1 by 16 into C. What was the value of C? The value of C was 991 minus 1, right? Once you have this, you need to multiply this. How do you multiply this? Rows into columns. You have to multiply rows into columns. So I'll get therefore X, Y, Z is going to be equal to first row into first column. 1 by 4 into 9 will give you 9 by 4 plus 0 into 9 plus 1 by 4 into minus 1 will give you minus 1 by 4. Next, second row into first column. This is going to be 1 by 16 into 9. That's 9 by 16 plus 9 by 4 minus into minus plus 3 by 16. Now third row into first column. That is going to be 11 nines are 99 by 16 minus 9 by 4 minus into minus plus 1 by 16, right? Therefore you can say that X, Y, Z is going to be equal to, this is 9 by 4 minus 8 by 4, minus 1 by 4, that's 8 by 4, which is going to be equal to 2. Now 9 by 16, I will take 16 as a common denominator, in which case I will get 9 plus 18 minus 3, right? 15 plus, this is going to be
9 fours are
9 fours are, so this is 36, 33 plus 9 plus 3, right? So this is 39 and 9, right? 48 by 16, 3, right? And the last one is 16 as a common denominator, 99 minus 36 plus 1, 100, 64, 4, right? Therefore you will get X is equal to 2, Y is equal to 3 and Z is equal to 4, right? That's how you solve the sum if they tell you to solve the sum by inverse method. Fine, do we get this thing here? Okay, this finishes this chapter. We'll stop this here for the day. Thank you very much.